All right, good morning, everyone. So yesterday when we went through those practice problems, we were trying to find the volume of the gas. So we were trying to find how big the gas was in terms of liters. And what we're going to be doing today is we're going to be showing how to use the ideal gas law to find the temperature of the gas. So T in the formula is going to be the unknown variable, and that's what we're going to solve for. So we're still working on the ideal gas law, and this would be considered like part 3 of these notes. So ideal gas law part 3, write that down in your notebook. And today we're going to answer the question, how do we find the temperature of a gas? How do we find the temperature of a gas? So if the number of moles is given to you and if the pressure is given to you, then how do you find the temperature, right? That would be the missing piece. Okay, so this is the basic formula, right? PV equals nRT, and we're trying to find T. So take a second, pause the video. How could you rearrange this equation to get T by itself? All right? Okay, so here's how you do it. This is easy for some people, but it's harder for others. It all depends on how good you are at algebra. When I was in high school, I wasn't very good at algebra either, but I'm going to show you how to do it right now. So first of all, how do we get it on the left side? Because right now T is on the right side, right? But there's an equal sign here. So anytime there's an equal sign, you can take the left side and the right side and just flip them around. It means the same thing. So nRT is equal to PV. So we know that that's true as well. And then we need to get the T by itself. So to get the T by itself, we need to get rid of everything next to the T. And that means we have to get rid of the N and we have to get rid of the R. And in order to get rid of the N and the R, we have to do the opposite of what's currently being done to them. And right now they're being multiplied together, N times R times T. So to get rid of N and R, we have to do the opposite of multiplication, which is division. So we have to divide this side by N and R. So so we're taking N times R times T and we're dividing by N times R. And that's going to cancel N and R from the left side. But remember, whatever you do to one side of an equation, you have to do to the other. So we're going to divide the right side by N times R. And that's how we get T by itself. So T is equal to pressure times volume over number of moles times the gas constant. So PV divided by N times R. All right, so this is going to be the formula that we're going to be using today for all of our practice problems. So just remember that T equals PV divided by N times R. Okay, so download Gases Part 3. It's the worksheet attached to this assignment. So Gases Part 3, again, there's 10 practice problems. Each one has a correct answer at the end, so you can check your work and see if you're doing it correctly. We're going to go through the first 5 together, and then you're going to do the next 5 on your own. All right, so make sure you write nice and neat. Follow the steps step by step. Make sure you pause the video. You'll get a lot more value from these lessons if you pause the video and check your work. Let's go through the first problem. Number 1, a 250 milliliter bottle is filled with 1.5 grams of carbon dioxide gas at a pressure of 4 atm. Calculate the temperature of the gas. All right, so temperature equals pressure times volume over N times R. All right, so P is pressure. What's the pressure of this gas? Well, it said 4 atm in the word problem. So P is 4 atm. I'm going to multiply that by the volume. How big is the gas? The volume. It says 250 milliliters, okay? But remember, we can't put 250 milliliters in here. We have to convert it into liters, and liters are bigger. They're 1,000 times bigger. So that means that 250 would become 0.250, 0.250, all right? It's 1,000 times bigger of a unit, so the number has to become 1,000 times smaller. Just move the decimal point to the left, just like this. So that's the pressure times the volume. The bottom is going to be N times R. So, okay, so N is basically the number of moles, all right? Now, we don't know the number of moles, but we do know the number of grams. They say 1.5 grams of carbon dioxide gas, all right? So we're going to take 1.5 grams and we're going to divide that by the weight of carbon dioxide. So look it up on your periodic table. Remember, carbon dioxide is not an element, it's a compound. So we have to look up all the parts of it. Carbon dioxide is CO2, right? CO2. So what's the weight of CO2? Well, if you look it up in your periodic table, I have mine right here. Carbon is 12, right? And oxygen is 16, but there's two of them, right? O2, 16. So 12 plus 16 plus 16, right? So to find the weight of the entire chemical, we just have to take 12 plus 16 plus 16. So that's going to give us 44 grams per mole, right? Whenever you look up the weight from the periodic table, it's always 44 grams per mole. And that's going to go here underneath the weight of the chemical from the word problem, right? This is like the weight of the sample on the top, and this is the molar weight of the chemical on the bottom. This is how heavy it is, and this is how heavy it should be. And if we take those two numbers and divide them, we'll get the number of moles, aka the number of particles. Okay, we're going to take that and we're going to multiply that by R, which is the ideal gas constant. I might need to give myself a little bit more room here. So 0.08206 ATM times liters over moles times Kelvin. Everything is going to cancel in terms of units, except for one unit. So ATMs cancels, liters cancels, grams cancels, moles cancels. So the only one that's left is K for Kelvin. So let's plug this into our calculator. This is how I'm going to plug it into my calculator. I'm going to do everything on the top first. So in parentheses, 4 times 0.25. You can do this on your calculator as well, even if you're using your iPhone or whatever. Just turn it sideways, and you'll see the parentheses button show up. On the bottom, we have to do this 1.5 divided by 4.4. Excuse me, 1.5 divided by 44. We have to do that in its own parentheses. So do another set of parentheses and do 1.5 divided by 44, and then close that parentheses. And then multiply by 0.08206, and then close the other set of parentheses. If you do it this way in your calculator, everything will go in the correct order and you'll get the correct answer. So, do this in your calculator real quick. Make sure you're getting the same answer as me. Make sure you know how to plug it in. And I got 357.462 Kelvin. So don't forget to add the K to the end, all right? So that's how hot the gas is. Sounds really hot, but remember, Kelvin always seems hotter than it is because it starts off at 0. It doesn't have any negative numbers. It's 273 degrees higher than Celsius. So remember, 357 degrees Kelvin might not be as hot as you think. Okay, let's do a little squiggly line here, and let's do number 2. So we're going to use the same logic for number 2. Temperature equals pressure times volume over N times R. Okay, number 2. A 350 milliliter bottle is filled with 1.5 grams of nitrogen trioxide gas. It says NO3, so we know what it is. At a pressure of 0.9 atm, calculate the temperature of the gas. All right, so P is pressure. That's easy. That's just the atm in the problem. 0.9 atm times the size of the gas. Now it's 350 milliliters. But in terms of liters, what would that be? That would be 0.350 liters. So that's P times V. The bottom is going to be N, which is the number of moles. So let's take the weight of the chemical in the sample. So just read that from the word problem, 1.5 grams. And we're going to divide that by the molar weight, which comes from the periodic table. So NO3. NO3 is the name of the chemical. So nitrogen weighs how much? Look it up on the periodic table. Nitrogen weighs 14. Oxygen weighs 16, but don't forget there's 3 of them. So we have to add up all the different oxygens. 14 plus 16 plus 16 plus 16 equals what? I got 62, right? So the answer is 62 grams per mole. That's the weight from the periodic table. So I'm going to write that here on the bottom, right? 62 grams per mole. So I'm going to take the weight of my sample divided by the molar weight. The first number on top comes from the word problem. The number on the bottom comes from the periodic table. Okay, let's multiply that by R, which is 0.08206 ATMs times liters over moles times Kelvin. Really quickly, I want you to show me what units cancel. So ATMs cancels because it shows up on the top and bottom. Grams cancels, moles cancels, and liters cancels. So again, K for Kelvin is the only number is the only unit that is left. So now I'm going to plug all of this into my calculator. So 0.9 times 0.350 divided by 1.5 divided by 62, all in its own set of parentheses. Make sure that's in its own set of parentheses, times 0.08206. Okay, I got 158.664 Kelvin. All right, let's do a little squiggly line and let's try number 3. Number 3. Come on, scroll. There we go. All right, number 3. A 975 milliliter bottle is filled with 0.75 grams of helium gas at a pressure of 7 atm. Calculate the temperature of the gas. All right, so temperature is equal to P times V over N times R. So P is pressure, and the pressure in the word problem for number 3 is 7 atm. I'm going to multiply that by the size of the gas, which is 975 milliliters, so that would be 0.975 liters. All right. Okay, on the bottom is N, so that's the number of atoms or molecules. So we have to take the weight from the problem, 0.75 grams, and we have to divide by the weight from the periodic table. So what type of chemical is actually being discussed in this problem? It says helium, right? Helium gas. That's really easy. Helium is an element, so we just have to look at the one number, right? Just find helium on your periodic table, and it has a weight of 4 grams per mole. So I'm going to write that on the bottom. So again, the top number comes from the word problem, and the bottom number comes from the periodic table. I'm going to multiply that by R, which is 0.08206 ATMs times liters over moles times Kelvin. And I'm going to, let's see here, I'm going to cancel ATMs, liters, grams, and moles. Okay, now I'm just going to plug all this into my calculator like this. So 7 times 0.975 divided by, double parentheses, 0.75 times, divided by 4, close the second set of parentheses, times 0.08206, close the first set of parentheses. So what's my answer going to be? So 7 times 0.975 divided by 0.75 divided by 4 times 0.08206. Okay, the answer that I got was 443.57, let's see here, 578, right? That's how it would round, because I got 787. So I'm thinking about this third number. What would it round to? It would round to an 8, because the other numbers after it are close to 10. And put a K there for Kelvin, don't forget. And put a box around the whole thing. So that's actually pretty hot. 443 Kelvin is almost 200 degrees Celsius, so that's definitely hot enough to burn you, seriously. All right, number 4. Number 4. A 2.45 liter bottle is filled with 5 grams of argon gas at a pressure of 0.55 atm. Calculate the temperature of the gas. Okay, so temperature is equal to pressure times volume divided by N times R. So P is pressure, and that's 0.55 atm. And then V is volume. And that has to be in liters, but luckily it's already written in liters in the problem. So we're just going to write down exactly what they tell us, 2.45. We don't have to change it like we did in the previous problem because it's not written in milliliters. We don't have to convert it. It's already written in liters. So we can just use that number as it's written, 2.45 liters. On the bottom is going to be N times R. So N, the number of moles. We get that by taking the weight of the sample and dividing by the molar mass from the periodic table. So argon gas. Argon, if you look it up on the periodic table, is just an element by itself, Ar. It's element number 18, and it has a weight of 40 grams per mole. So it's pretty easy. We don't have to look up multiple pieces. We don't have to look up multiple elements. It's just one element by itself. And we're going to multiply that by R, which is 0.08206. 8206, there we go. ATMs times liters over moles times Kelvin. So let's divide some of these units out. ATMs is going to cancel, liters is going to cancel, grams is going to cancel, and moles is going to cancel. So K for Kelvin should be the only unit that's left. It's really important that you show me that you're doing that so I know you understand the basic process of how we're getting this final unit. I'm going to plug everything else into my calculator like this to get my final answer. And I got, let's see here, I got 131.367 Kelvin. All right, number 5. Last one we're going to do together, and then you guys can just do the rest on your own. Hopefully this is making sense to you. If not, just send me an email and let me know. Number 5, a 0.175 liter bottle is filled with 0.66 grams of oxygen gas at a pressure of 3.75 atm. Calculate the temperature of the gas. All right, so temperature is equal to pressure times volume divided by moles times the gas constant R. So P is pressure. That's going to be 3.75 atm. I'm going to multiply that by V for volume, which is 0.175 liters. Again, I don't have to convert this number because it's already expressed in liters. If it was milliliters, then I would have to divide it by 1,000. But it's not. It's written in liters, so I don't have to do anything with it. Divide that by N times R. So N is the number of moles, right? We have to say how heavy it is, 0.66 grams, divided by the weight of the chemical in the periodic table. And it says oxygen gas. That's really easy. Oxygen is 16 grams per mole. I bet some of you even have that number memorized at this point. And then I'm going to multiply that by the value for R, which is 0.08206 atms times liters over moles times Kelvin. All right, so my final answer will be, well, I'm going to divide out all the unnecessary units first of all. So I'm left with just Kelvin. And my final answer is going to be 3.75 times 0.175 and divided by 0.66. Make sure you do double parentheses here. 0.66 divided by 16. Close the parentheses times 0.08206. Close the other set of parentheses. And then just plug it all into your calculator exactly like that. 3.75 times 0.175 divided by 0.66 divided by 16 times 0.08206. And I got 193.871 Kelvin. So that's my final answer. Let me know if you guys are struggling with these problems at all. The only thing that you got to watch out for is it written in milliliters. If it's written in milliliters, you have to divide that number by 1,000 to turn it into liters. So if it's 500 milliliters, that's 0.5 liters, right? If it's 50 milliliters, that's 0.05 liters. Just take whatever number they give you and divide it by 1,000. That's how you convert milliliters into liters. And the other thing that could trick you up is if it's like a compound gas, like carbon dioxide or carbon monoxide. You have to look up the different parts of the gas on the periodic table and then add those weights together. All right. Let me know if you have any problems. When you're done, upload a picture of all of these problems to Google Classroom. So I want you to upload a picture of your work for questions 1 through 10. All right. Good luck, and I'll talk to you guys soon. All right.